I'm going to do F today. That's what I was reading. Wait, guys.
F is an all.
Yeah, man. F was here.
I already did.
Supposed to have done it. There's
a couple questions.
There's like totally meager on the test that's on F, but like
No,
you have the Algebra 1 skills to do it, even if I didn't.
It's easy. It's easy, but
I wouldn't hurt you guys with that. Okay, so let's talk about the review if you don't mind. All right. Also, does anybody have, other than the review, does anyone have anything they need to submit to me? If you do, bring it on up. Please make sure your name's on it. If you need to staple it, stapler's up here as well. So I wasn't sure. And then what did I give you guys last night?
6G.
G? Unless you're looking on Schoology, and then it was like, 6P or something. Stuff's all jacked up. All right. Hope you all are well. My adventures with you guys continue. Let's see. That. All right. What kind of questions did we see on 6G that we would like to talk about? Go ahead. 13. All right. The synthetic division one?
Yep.
Okay.
I know it is.
So number 13 says.
Yes. Yeah.
Yeah, I got like a
Actually, I did. So,
all right. So we're going to use the synthetic division. Are there going to be some zeros we need to put on this one, or does it go all the way down?
Yes.
We need some zeros. Good. So I'm going to divide by that.
4, 3, and
All right, so 3 for the fourth, I don't have that. For the 3, I don't have that. 5, the squared I do. For the 1, and there. That's the first part. And I will tell you that on the written part of the test, you will definitely see this type of opportunity where you have to add a 0 or 2. Okay? All right. Ready? Bring it down, multiply. Combine those. What do I get when I combine those? 27. Combine those, get 27. Uh-oh. That's going to be negative 81. What do I get when I combine those? Negative 76. Uh-oh, someone have a calculator out because I can't do this in my head.
No.
Negative times negative is positive. 76 times 3.
it's 2 times
228.
228. Cool.
Oh,
Uh-oh. So that's 228. Oh my gosh. All right, that's 228. 228 is going to be negative. I know that. And then 228 times 3 is 24. 2, 6, 8. 684, negative 684. Subtract that, so I get negative 677. Yeah. Woo. Did I do that right? I hope.
Wait, shouldn't it be 705? Negative 705?
Where did I make a mistake?
Oh, I added.
Okay.
7.
Okay. I was multiplying by old school methods, which new school methods are much better. All right. How are we doing?
yeah.
What else should we take a look at? Does that answer your question on that? Was that answer correct?
Yeah.
Okay. Yeah.
Well, I'm just wondering, since I think a couple days ago you said we're not going to have a graphing calculator on this test. So, like,
Bless you.
what's going to say 34 and 35 you don't need to do, right?
34 and 35. Let's take a look at it.
That's so toxic. So bad.
There aren't going to be questions.
Right. We're not going to have a local min, local max on it. We already tested on that, so that we should actually move that back a couple pages.
Yeah.
Yeah, that's good. So 34, 35 you will not see, which is good. It won't be on the quiz. Shh.
So it's all stuff
Yeah.
I sort of know how to do now.
I know this is really easy, but I wouldn't pay attention. So number 15. I remember you saying it was super easy. I just kind of forgot.
Kind of forgot. Okay. Number 15. We good?
Oh, there's 3B3 though.
Just like
15 you said, right?
Yeah.
There's 6. There's 6.
All right. So, shh. What's the degree?
6.
No, it's 3. We're not multiplying things together. It's already in standard form. So it's a third degree polynomial. I'm competing with voices, and there's more than what's in my head. And then identify. Okay, Wait, I just lost 15. And then we want to know as x goes to positive infinity, so that's going to the right, where does f at x get to? We'll talk about that in a sec. And then as x goes to negative infinity, so as it goes to the left, where is it going in the y direction? All right.
Can you just like draw the shape thing?
Yeah, so you know this is going to be a regular shape, third degree like that, right?
Yep.
So as I go this way, it goes to positive infinity. As I go this way, it goes to negative infinity. And that's it. If I would have had a negative out in front of this, that would have flip-flopped.
So it's the same as it is on the left side of the negative.
Say that one more time, I'm sorry.
So it's like the same as it is on the left side, like as the x. It's like the same on the right side as it is on the left, unless it's negative, right?
If you have a so if I had, without writing the whole thing out, if I had this, you know, plus everything else, that's going to look like this. And so it's going to change the top one to, as I go this way, it goes to negative infinity. As it goes this way, it goes to positive infinity. So, yes, ma'am.
But then for ones that have like even exponents in the beginning but a negative,
yep.
Is that like the...
Yeah, so if I had like f of x is equal to, let's say, 3x to the 6th with a whole bunch, this is doing that. But if I had f of x is equal to negative 3x to the 6th, then our end behavior is looking like that.
Okay. Wicked.
So 6 to the 4th to the 6th to the 8th to the 10th. No, we didn't. Yeah, we did not put any gotcha ones on there. Okay. What else? Yeah.
Well, so what if, will we have to like draw them like that?
Yeah. So.
'Cause if we do, can we just sketch it randomly like that?
Yeah, it's not going to be exact.
Okay.
So I'm going to show you one that we'll graph. So let's go down to like say, well, let's look at 29 through 33.
Okay.
Okay.
Yeah.
All right. So let me do 29 through 31, 32, and 33 first. Okay. I'm going to do all of these on the same graph. So this one is, what does y equals negative x to the third look like? So this is the only thing I'm kind of looking at when I'm grading it.
Okay.
You have a dot right there.
Okay.
Okay. It's going to go right through it. And this one's going to look like this.
Okay.
Okay. So I'm looking at that dot.
Yeah.
Now, the next one, if it was, let's do blue, f at x is equal to x to the third minus 3.
You just move it 3 down.
Yeah, so then I'm looking for this dot here. And then I'm looking that you have it going the right way. Does that make sense?
Yeah.
And then 33, I'm looking for two things on that. It's going to shift left, right, and it's going to shift up, down. Okay, so again, I'm identifying this dot as my first thing. So this is going left 2.
Yep.
So it's going left 2, and it's going down 1. Okay? And that's going to look like that. So that's really what I'm looking for when I'm graphing it. If you can't draw the perfect, you're...
You get the butt.
Yeah. I mean, as long as you're not going, hey, it looks like this, you're getting it wrong. Yeah.
Wait, so how do you draw wiggles?
Okay, let me get to it. So we go down 31, 32, 33. So you'll definitely see this type of problem. Okay, and again, we're not looking for the artistic ability. We're looking at, do you understand how these graphs go the way they do? Of course, if I had the parent function, y equals x to the third, you just have to realize that one looks like that. That's the basic one. Okay, and then because I have the negative, it kind of flips it over the y-axis because I shift it down. You know, so this black and blue look the same. It's just this moved down. The black and the purple look the same, but it shifted left and down. Okay.
And then the even ones look like an M thing.
Mm-hmm. But you're not going to have any of those for this type of approach. You'll have a bunch. You'll have like 3 of them. That'll be x to the third. So we're just trying to get you to realize, what does it look like? Does it look like that? Okay. And then number 29 and 30 So I'll do these on individual screens. So 29, we have y equals x squared. And then we have x plus 3 squared. And x minus 6 to the third. Okay. So let's do this first. Let's get the roots. And I'm actually going to change something that they're going to call multiplicity. It's totally easy to do, don't worry. And then, does it bounce, wiggle, or cross? Okay, so I have a root here of 0. So what's the multiplicity of x squared? 2. It's to the second power. So you're just listing the exponent. And then, does that bounce, wiggle, or cross? Bounce. Okay. And then, what does this give me? Negative 3. What's the multiplicity of this?
2.
Yeah, it's raised to the second power. Does that bounce, wiggle, or cross? Okay. And then what's the answer that comes out here? 6.
It's a wiggle.
3.
And it's a multiplicity of 3, and it's a wiggle. Good.
Wiggle, wiggle.
Okay, is that all right so far? So when you're trying to graph these, your graph isn't going to look perfect, but there's certain things that should kind of stick out. Okay, and again, I'm doing mine like that. I do a double if it's a bounce. I do a triple if it's a wiggle. Is that the official term? No, it's kind of like the stirrup mode. Okay, all right, and then negative 3. I also have a bounce, so I'm doing a double. And then at positive 6. So I'm doing a triple on this one because I know a wiggle's taking place there. Okay, what degree would this exponent be? 7. Okay, so it's 7th degree. Now I want you to see something real quick. Remember we talked about the multiplicity in the beginning? Ready? 2 plus 2 plus 3 is?
4.
Oh,
wicked.
Okay,
Check.
so that's sure. All right, so if it's to the 7th degree, I know at the right it's going to kind of look like this somehow. So let's go ahead and make that. So here's my wiggle. Then it's going to come up, bounce, done. Am I worried about how far those come down? No. I'm just looking at here, here, here. So when I grade this, I'm going to say end behavior, perfect. Okay, not that you need, I'm just, where's it pointing? Do you have some sort of characteristic of wiggle here? You know, don't draw it straight down because that's a cross. Then I can see the bounces. Yes.
So when you need a cross, what is the, like if there's a cross in this, like what would the number be?
Okay, so
Does that make sense?
so our multiplicity would be 1. So on number 30, we're going to see a cross.
Oh,
And I'm going to work it
also,
out. Yeah.
I was wondering for that.
Yeah.
You know, it's like under the X.
Uh-huh.
What if it's like, what would like the numbers be like if it's on top? Does that make sense?
So if it bounced here,
Yeah. Would it be?
I don't know, let's make one up. All right, bounce on top. Let's do. Okay, so 4th degree polynomial. Is everyone okay with that? Let's see, -1, and that's a bounce. Agree?
Yeah.
+2, and that's a through. +6, and that's a through. Oh, you wanted a bounce, right?
Well, I was just wondering what
What would a
like
bounce
the
look like?
numbers it would be if it was like on
Let's do
top
that.
of the x-axis. That makes sense.
Trying to. So I changed that to a 2, so I'm going to make a bounce there. So that's to the 5th power.
Make it positive and then the bounce.
So it has to be positive, not negative.
Oh, I'm going to make a negative out here. All right, so this is now going to come like this.
Oh, so it has to be a negative in the front.
It doesn't necessarily. It's just when I'm making one up off the cuff, I'm kind of having to modify it as I think through it.
Okay.
Does that help you? And again, I'm not worried about. I'm not looking for how tall that's going and did I get to the absolute max or min. Okay. All right, so let's try number 30. Yeah.
If you go back to that last slide, when it says x to the second, isn't it supposed to be like a up, and then up again instead of going like
Right here.
yeah?
So
you see, like on the graph, it starts like positive and then goes down, but shouldn't it end in the positive direction too?
well, because I think I'm gonna answer this correctly. All right, you're okay with the wiggle.
Yeah.
And you're okay that this starts going to infinity.
Yeah.
Right. So because it crosses down here, and because we created a bounce here, it's not going to come up, because this indicates that it happened at 0. So it had to come up and bounce off it, and then bounce off it. So it's not going to go above it. If this was like x to the first power, it would go right through it. Or if it was to the third, it'd wiggle through it. Okay. Does that answer your question?
Yeah, it does.
Okay. Yeah.
So if it's positive in front, you draw it like below the axis, whereas if it's negative, you draw it above?
No. If it's positive out front, that just means the end behavior every time will on the right go to infinity. It has nothing to do if it goes above or below the x-axis.
Okay.
Okay? Does that make sense?
Yeah, so that's the only thing it changes.
All right, let's try number 30. All right, number 30 says f of x. It's got a negative out front, so we know it's going to be an opposite looking graph. So it might both be down, or it might be just flipped over. X plus 1 to the third. And x minus 4. All right. So roots, multiplicity, and bounce, wiggle, or cross. Roots, what does this give me? 6. What's multiplicity? So the first power, bounce, wiggle, cross. Cross. Good so far?
Yeah.
What does this give me?
-1.
-1, bounce, wiggle, or cross.
Wiggle.
Wiggle, what's multiplicity? 3. Okay, what does that give me?
4.
Bounce, wiggle, or cross. Multiplicity.
1.
What's the degree? Just add this up to the 5th. Okay, or 1 plus 3 plus 1, it's 5. So it's a 5th degree polynomial. Okay, because I have a negative out front, it's going to look something like this. So it flipped over. So at the right, it's going to go to negative infinity. And let's try and graph this. All right, so at positive 6, I have a cross. At negative 1, I have a wiggle. So that's what I'm going to do like there, just know this wiggle. And then at
That's one, not negative
That's
one.
1.
oh, okay. Undo. Whoop. Undo. Thank you. Let's see, negative 1. And then at 4, it's just going to go through. All right, so thinking about this, I'm starting at the right of this graph. So I'm at the right, yes? I know that this is going down. So this is going to come up, come down, change directions here, and then like have a wiggle right through there. There you go. Can you see there's a wiggle?
Yeah.
Does this look different than crossing? Like crossing, it just keeps going the same direction. A wiggle's like change up. Okay? Good?
Wait, are crosses always just
To the first, multiplicity 1. So a lot of times a cross is going to be if we had just x sitting by itself. Or we're going to have x plus 1 without an x1 outside of it. All right, put that away. We can review more of that tomorrow. I wanted just to hit you on 6F. This is pretty quick. I have plenty of these, I believe. Everyone's good today?
No, no, it's not a good
What's
day.
wrong? Why?
I'm
What
actually having a really great day.
Oh, good.
If you wanted to know. I'm just stressed. I'm 1:30. Unless it's
Hey man, at least it's almost weekend.
True. And I like positive outlook.
Lieb, I think I counted right, but you don't pick it on you.
Right now. I'll get the easy picture. Yeah, I'm doing a little bit of
Hey there.
Seemingly.
What you got? Oh, this is good. Is this an escort?
No.
Okay. Oh, he's here. What did he do?
I don't know.
Let's see.
Mr. Watson.
What did you do?
Did you snort crack in the bathroom
What's
again?
bad?
Oh, okay then.
All right, let's go to the front. Does everyone have notes? Lee, enough?
Yeah.
Good. Yay. Miwa, enough? Angela, enough? Get you enough? All right, sweet. Yay. All right. All right, so my plug, if you are 16 and you have parent consent, and I know that you can have your parents call and give consent, you should give blood. And the reason why, I'm going to give you 2 reasons that you should give blood. Two. First one, the small pinch that you feel is nothing compared to the pain that the person who needs your blood is in. That's number 1. Yes?
What if I want to donate blood but my parents won't give consent?
They
Why
won't?
won't they give consent? No.
I bet you they
They
won't.
just won't. No,
Or
they
just
won't. I asked.
NHS.
Aaron won't because I get 2 hours for NHS, which is like part of the reason I want to do it because I need hours. But I also want to do it just to be a good person.
It's a good
But my
person.
mom won't let me.
Well, give her those 2 reasons. The first reason, the pinch that you get from that is nothing compared to the pain that the person's in who needs your blood.
Tell Aaron. Imagine.
Item number 2.
I think it's
Item number 2. I have heard this from numerous doctors in my medical class say this flat out. There are 9 cancers that if you donate at least once a year throughout your life, and it doesn't really matter when you start, there are 9 cancers that are out there that if you give blood at least once a year, your risk factor drops 90%.
Dang, wow.
Yeah.
Is it only today?
Well, they'll take blood any day, but here, yes, we have it here.
What are the cancers?
Like I just don't.
Well, one you can't get ovarian unless there's something I don't know about you. I guess that we as a nation need to get to the point. I can't ask it. Are you a boy or a girl? But if you have ovarian, colon cancer, we all have colon. Unless you have a prostate back then, you don't know. Lung goes along with leukemia, so that's the blood. It goes with prostate, which that's males. And I have to think the other 4.
No, that's
Can't think
all
off the
right.
top of my head. But I mean, like they're like the big ones. It's not like, oh, you have cancer as your fingernail. Some cancer no one's ever heard of. It's like these guys are like legit saying, dude, this lowers rate. Because it has something to do with because you're taking so much. Your red blood cells are having to reproduce so quickly, and it's a good thing for your body.
How long is it not there?
Huh?
How long can you donate blood?
I think until 1:30 or so.
Today?
Yeah.
That's not it.
Do you need forms or something? Or?
Yeah, but they do a lot of the stuff online. So if you go there, bring your iPhone, and then you do the stuff online while you're sitting there, and boom, they do a little finger prick, check, make sure that your hemoglobin's right, and go get blood. And I tell you, it doesn't hurt. If you're squeamish of needles, just look away.
What if you pass out? What would they?
You're already sitting down.
What if you pass out after? Like
Well,
in the
here's the
office?
funny thing. 2 times ago when I gave blood, this was last May, I usually kick my shoes off. I'm like totally chilling. I'm like, this is great. So I'd go put my shoes back on after I get done. Get up, I'm like, oh crap. I felt my vision coming in like this. I was gonna drop.
My
I'm like,
Scott passed out, and then
I'm
like
dropped.
cute girl keeps doing a cute girl. He found run away, but then he found her glove. But then he found her.
was it Cinderella or something? All right.
It's Cinderella, except they just cut off the toes.
All right. So, are we okay on synthetic division?
Wait, can you just?
That's what happens.
I'll do it.
Cinderella.
All right. -1, yes? -1?
Yeah.
What's next? 0. Why is 0 next?
Because there's no three.
Good. And then I put a 3, and then a 2, and then a 5. Everyone good with that?
Yes.
Anybody like, I don't get it.
No.
If that's you, come see me. All right, bring it down. Multiply. There's your answer. That's it.
Cool.
Okay.
Okay.
Moving on. Good to go?
Yes.
Yay. No? You needed it? I'm sorry. I apologize.
No, it's easy.
No, I don't get this.
If you want to come see me, I'll get you on a couple of problems. I'll get you clear as mud.
Good?
Wait, whoa.
Well, when
Sorry, I'm good. Thank you.
Drew's back here, wrap it up.
I'm not going. I'm not going to the game.
They're gonna come do an escort. You're just gonna run. I mean, they send you, a student to come be your escort. Like, what are you gonna do if I run? I don't know.
If you run from an escort,
That'd be
you
hilarious.
get less suspension time than like if they actually like catch you just in case.
Yeah, someone else's homework. I know. It's a serious offense. I know. All right. If we go to multiply binomials together, what you basically have to do is you're gonna just, in whatever order you want, you have to do that and then bring the next one down. Now, let me pause because some of you might not see how I did it so quickly.
That was easy. Good job.
Okay? So I just have to pick two of my binomials, multiply them together, and then I'm going to have to multiply these. So this will be over here, over here, over here. So that's x to the third plus 7x squared plus 12x. And then here, here, and here. So then plus 5x squared plus 7x plus 60. Like terms, I don't have any other x to the thirds. X squared, so that's 12x squared.
Isn't it
35x.
Where?
7x should be 35x.
No way.
Yeah.
This right here? Dude, thanks for getting that. All right, and then that's, what, 47x? I love the fact that you guys know how to do arithmetic. If you had a teacher that could do arithmetic with you guys' skills, man, you guys would be like in abstract algebra stuff. Yes?
Couldn't you, since there's nothing like in front of the x things in all three of them, couldn't you just be like x to the third, then x to the like 12, and then like do the math stuff from there?
You might be seeing it the right way. Just double check it. Make sure. So the only thing I would think on this that I would try and legitimately do is they said, hey, what's the degree? I know x times x times x is x to the third. And if they said, hey, what's the constant, which is down here? 3 times 4 is 12 times 5 is 60. And then I can't see it on the stuff in between. My brain's not wired that way. Cool. I've been broken for years.
I mean, we're all broken.
Can I move on?
Yeah.
Everyone happy? All right. So is this one going to be done the same way? So pick two of them. And then is that okay? I think I did it right. I didn't change colors. Is that okay? Sure. Walk around, greeting people, taking pictures, signing autographs. It's kind of cool. All right, so then I'm going to combine like terms. So x to the third minus 12x squared plus 47x minus 60. Okay, same idea. Are there any of these that I need to multiply out again? No. Anyone need to see any more of these multiplied? If you let me know if you do.
No.
Go on what? You guys say what?
No.
No more?
No.
Anybody?
No.
Going once?
No.
Twice.
Going twice? It's up to Drew if you work them out.
No.
He's just gonna be a smart aleck and say, do them all. Do them all just so your back's turned to me so I can walk around the room some more.
Exactly.
All right. We good to move on? Or yes or no?
Yes, sir.
Anyone losing sleep if I don't? Okay.
No.
See, I'm not gonna get sleep either way.
All right. So then you remember the special patterns. X squared 16 plus 4x. Okay. Or this one, 9x squared plus 25. That should be an 8x, excuse me. Sorry. So multiply those together, 15, and double it. Okay, or just FOIL it out if you don't remember that. So this is then a squared plus 2ab plus b squared. And then this one would be a squared minus 2ab plus b squared. Okay, so there's certain patterns that you could maybe start identifying. But what's always hard for me when they start sharing patterns with you on just two binomials, it's like, but how much time are we really saving by seeing the pattern? You know, it's not like you have some big old problems like, yeah, you know what, if you just multiply everything by 6, look at that. And you're like, oh. I'm just made something up that I don't think there's any shortcut that you can multiply by 6. May I move on?
Yes.
Anyone stuck on any of this?
No.
And you all understand that this means the same thing as this. A minus b times a minus b, yes?
Yep.
So just multiply that out if you're like, way, okay, I see it now. Right?
Yep.
Moving on?
Moving on.
Giddy up. All right. Difference of two squares. Nice thing about when you see this, if you have conjugates of each other, meaning one sign different,
Minus 64.
you're done. This one, they're conjugates because you have one sign different. Again, they are. So, the one sign different of conjugates. If you have the exact same binomial, there's one sign different, the middle terms fall out. So, that's kind of nice that you could get to save a little bit of time on that. Itching. Told me to keep it on for 4 hours or I'm going to leak again. We good to go? Can I move on? Okay.
Do it.
All right. So what do we get when we cube a binomial? Okay. So I'm going to work this once like this. Okay. So I'll multiply these two. And multiply by this. And then just realize this, x to the third plus 6x squared plus 12x plus 8. There you go. That is called a perfect cube. I will just say polynomial. Because I took the same exact binomials, multiplied them together 3 times.
Yep.
What's that?
Yeah,
Yeah, I just foiled together the first 2, and then I distributed the x plus 2. So I went here to here, here, and here, and then here's. That's it. Take this off, man. It's itching. Can I move on? Yeah, I'll just lick it till it stops bleeding. Can I move on? Good? Yay? Almost done. All right.
This is chump change.
This is the exact same thing. Is everyone okay that this is? Thank you. And I think what we're trying to devise on this is we're trying to get you all to see the pattern. And I'm going to show you a shortcut on these. Not today, but does everyone feel comfortable with that? And then you just multiply it out? Anyone need me to multiply it out?
No.
Sure? Okay.
Thank you. I take pride in my house.
Combine like terms?
A lot of writing.
Yeah, we're killing trees today. Except for Drew. He's boycotting it. Alright, helpful things to know. If I square 2, 2 times 2 is 4. If I cube it, I get to 8. Still with me? If I square 3, I get to 9. If I cube it, I get to 27. Still with me? If I square 4, I get to 16. If I cube it, I get to 64. Still with me? If I square 5, I get to 25. If I square, or if I cube it, I get to 125.
Are we gonna get to use like
What do you want?
calculators?
Not got.
You can use any calculator you want except for graphing. And then it's what, 49 and 343. And 8 times 8 times 8, that's 64. So then that's 512. And then that's 81. So 729. 729, not 799. Sorry about that. It's a 2 right there. Good with that? Do me a favor, someone have a calculator out real quick. All right, take any 2-digit number you want and cube it. So, I mean, just multiply, so raise to the third power, multiply. Okay, don't tell me what you cubed, or don't tell me what the number was cubed, but tell me what, is it like a 5-digit number or a 6-digit number?
6.
It's a 6-digit number? Give me the 6-digit number, would you?
474552.
Did I write it up there correctly?
Yeah.
Split it in half, 2. All right, so 8, 4, 74, 78.
Yeah.
What?
Oh, I see.
3, 2, 8, 5,
3, 2, 8, 509. All right, that's a 9 through 28. Oh, of course, 69. All right. I just took cube roots of 3-digit numbers in my head. Yay. I'll show you that trick a different day. All right. All right. So how do you simplify these? Well, 28 over 49. 7 goes into both. Is that okay so far?
Yep.
Tug of war, top and bottom. Who wins?
Top.
Top. How many?
2.
Done. Cool. This one's kind of goofy. You have to realize this goes in there twice and there once. So then it gets 2x plus 1. Is that okay?
Yep.
Now, I'm not quite sure if this is a misprint or something, but it's like, how would you do this? 11 over 4. How'd you get that? So I think it might have been a misprint. I'm not sure, but I don't think we're trying to get this one to say, hey, this is the same thing as 7 over 4 plus 1. I don't think we're trying to get to that. Am I done?
Yes.
No. Okay, so to simplify rational expressions, algebraic fractions, you must first. I don't know. Binomial term sounds good. Oh, factor. Yay. Okay. We good on time? I'm still good. Ready? Difference of 2 squares. Agreed?
Yep.
So, and then I have x plus 5 on bottom. When you have a binomial that's factored, put it in parentheses. Those cancel. This gives me x minus 5 for an answer. All right?
Yep.
If I factor this one, x minus 4, x plus 1. And on bottom I have x minus 4. I'll put that in parentheses. What cancels? Good. Seem okay? Almost done. Last one. So I have a negative I know I have to deal with at the very end. Put that over there. So x minus 8, x plus 2 over x plus 2, x plus 2. So factor out or cancel one of the x plus 2's. So I get negative x minus 8 over x plus 2. Was that it?
Yep. Yeah.
Really? Good. Yay. All right. So let's do this. Yeah, we should be able to. What are we doing today? What did I just lecture on? F? All right. So worksheet 6F. Worksheet 6F. Make sure if you're going off Schoology, to print. Make sure you double check them.
Yeah, the Schoology's all effed up.
Yeah, well, it happens. Clayton. Or wait, Cooper. What are we doing? No, what are we doing? Grant, Cooper and Grant.
I don't know. He asked you first.
Yes, you second.
Right?
Go home here.